The next unit of concentration that we will cover is molality. These are very similar. They sound similar. One is molarity, what we just covered. The next one is molality. Molality, which is written with a little m, is also called molal concentration, is determined by dividing moles of solute by the kilogram of solvent. This is used typically when we want to eliminate the volume of the solute or the solution, because volume can vary slightly with temperature. So if we have an experiment where it's sensitive to volume, then we would use molality instead of molarity. Note that the moles of solute are the same for both molarity and molality, but what changes is the bottom part. This one is kilogram of solvent, whereas molarity is liters of solution. Here, for molality, we only deal with solute and solvent, not with solution. Let's take a look at some examples. Here's some sample problems where we have the moles of sucrose dissolved in this much water. So all of these are water. Some are moles and some are grams. I will do the last one for you, then give you a chance to do A, B, and C on your own. We will be using this formula, and molality, once again, is moles of solute over kilograms of solvent. So in a problem that deals with molality, first thing you need to do is determine, do I have moles of solute? Do I have kilograms of solvent? If I don't have moles of solute, like part D here, I don't have moles, I have grams, then can I convert to moles? Can I figure out the moles? Yes, I can, because I have a mass in grams and I have the formula, so I can use the molar mass to convert grams to moles. What about kilograms of solvent? Well, I have grams of solvent, but I know how to convert from grams to kilograms. So here we go. I can take what I'm given, 12.1 grams of CH3OH, multiply by 1 mole of CH3OH weighs 32.04 grams. From the periodic table, I can figure that out. Then my grams will cancel, leaving me with moles on top. 12.1 times 1 over 32.04 gives me 0.378 moles of CH3OH. And I figured out the moles of solute. Now let's figure out the kilogram of solvent. Well, I have 275 grams of water. To convert that to kilograms, I have to divide it by 1,000, and that gives me 0.275 kilograms of water. Now that I have both of these, I can go ahead and solve for molality. Molality then is 0.378 moles of CH3OH over 0.275 kilograms of water, giving me 1.37 little m molal of CH3OH. Now go ahead using this formula and work on A, B, and C on your own. Let me work another example problem for you. Rubbing alcohol is a mixture of isopropyl alcohol and water, and that mixture is 70% isopropyl alcohol by mass. So this kind of combines another unit that we've talked about. If the density is 0.7 grams per milliliter, or I can rewrite it as 790 grams of solution over 1 liter of solution at 20 degrees Celsius, express the concentration of rubbing alcohol in molarity and molality. Okay, let me write those formulas side by side, right? Or on top of each other. So molarity is moles of solute over liters of solution. Molality is moles of solute over kilograms of solvent. Okay, so what do I know? I don't necessarily know the moles of solute yet, but I do know that I have a density of 790 grams for my solution per 1 liters of solution. And I also know that it's a 70% isopropyl alcohol by mass. So I can start by using my density, 790 grams of solution, multiply it by 70% is nothing else but 70 grams over 100 of my solute over 100 grams of solution. That's what 70% tells me. Okay, that cancels my grams of solution, leaving me with grams of my isopropyl alcohol per liter of solution. Now I can convert this from grams into moles by using the molar mass of isopropyl alcohol, which is 60.09 grams. So multiply by 1 mole over 60.09 grams. The grams are going to cancel, leaving me with moles of C3H7OH over liters of solution, which really is molarity. So that gives me 9.2 molar solution of C3H7OH. For this part, it's important to understand that my density is the grams of solution per liter of solution. That's what the density means. Density belongs to my solution, not my solvent or my solute. Whereas the mass percent is given as grams of my solute over grams of solution. Okay, so then I could cancel my grams of solution. Then I could use the molar mass to get rid of grams and convert to moles of my solute. So moles of solute over liters of solution is what I've got left, which is really molarity. And now that I have that, let's figure out how to use molality. Once again, this 790 grams of solution is basically, it's my solution is not just solute or solvent. Okay. Now, if I kind of did this back calculation, I didn't show it here, but I can calculate how much C3H7OH I have in that 70% alcohol solution, and I get 553 grams out of that 790 gram if I use 70%, right? So if I take 553 divided by 790, that gives me 70%. Okay, so 553 divided by 790 grams, that gives me 70%. So 790 minus the mass of my solute gives me just the mass of water. So I have the mass of solute and the mass of water given me, and I can convert this from grams to kilograms by dividing it by 1,000, giving me 0.237 kilograms of water. Now that I have from up here, I have the moles of solute. Even though it's in one step, I can just divide the two to give me moles. And I have the kilograms of water. I can use those, right? 9.2 moles per 1 liter. So I have 9.2 moles of C3H7OH divided by 0.237 kilograms of water, giving me 39 molals of C3H7OH. Okay, so a couple of things to note here is that what I have as density, I can write it as grams per liter. If I write it as grams per liter, I have to multiply it by 1,000, so 790 grams per liter. This belongs to the solution. The 70% belongs to my mass percent, so it's solute over solution. And then the molar mass of my solute will convert if I do all of this, we'll convert it to molarity, moles per liter. And then I can take that 790 grams of solution, subtract the 553 grams. So if I take 790 multiplied by 0.7 would give me 553 grams, and that's how many, what percent basically, or the amount in grams of C3H7OH I have. If I do the difference between these two, that leaves me with the mass of my solvent. If I have to divide it by 1,000 to give me kilograms, and then I use the 9.2 moles per liter. So I have 9.2 moles divided by 0.237 kilograms, giving me 39 molals. Go ahead and follow the previous slide and work on the same. So this is exactly the same as that one. And I've already calculated and given you the molar mass of H2SO4.